Class 11th Chemistry, Unit 6 Thermodynamics. In this video, we will discuss about pressure volume work and reversible and irreversible process. First come to pressure volume work. A cylinder contains 1 mole of an ideal gas fitted with a frictionless piston. Initial volume of the gas is Vi and pressure of the gas inside is P. And if Pex represent the external pressure and this external pressure is greater than the pressure of the gas inside the cylinder, then what will happen? Piston is moved inward till external pressure becomes equal to pressure of the gas and final volume reached is Vf. During this compression, piston moves a distance L and its cross-sectional area of the piston is A. Now see this diagram. This is a one cylinder and this cylinder contains 1 mole of an ideal gas. Okay, and this is a frictionless piston. Pressure of the gas is represented as P. Initial volume is Vi and we are applying this external pressure which is represented as Pex. When this Pex is greater than this P, this piston will move inward. Okay, and this cover the distance L. Okay, this can also be represented in this diagram. This represent the initial volume Vi. This is external pressure. When this external pressure is greater than the pressure of the gas inside the cylinder, then this compression will taking place and final volume is reached Vf. Okay. Now, volume change is given by L into A and this is equal to delta V and this is equal to V final minus V initial. And whatever the pressure we are applying, this pressure is equal to force divided by area. And that's why force on the piston is equal to P external and area of piston is A. That's why P external multiplied by A. If W is the work done on the system by moment of the piston, then W is equal to force into distance. And what is force? This one. Okay, that is P external into A. And what is distance? Distance is L. Now in this case, this A into I, this is the change in volume, that is V final minus V initial. That's why we can write W is equal to P external V final minus V initial and this is given as delta V. That's why we have relationship W is equal to minus P external delta V. Sometimes this P external can be written as P. We are having W is equal to minus P delta V. Now what is the significance of this negative sign? Okay, now just see. The negative sign of this expression is required to obtain conventional sign for W, which will be positive. We already discussed. If work done on the system, then that will be considered as positive, and work done by the system, that will be negative. Now in this case, compression work is done on the system. That's why W should be positive. And as we know, during this compression, this V final minus V initial will be negative. Okay, and this negative multiplied by negative will be positive. That's why this minus sign is put here. Okay, now this formula is also applicable for expansion work, which is done by the system. So it will be negative. In expansion, V final minus V initial will be positive. That's why we can say this formula W is equal to minus P external delta V is applicable for compression work as well as expansion work. Okay, in case of compression, this will be negative and this negative is multiplied by negative, we will get work positive. Okay, and in case of expansion, this delta V is already positive, and when this positive is multiplied by negative, we will get the negative work. That's why work of expansion is negative, because this is done by the system and compression work is done on the system. That's why it should be positive. Now, what is the meaning of this reversible process? A process or change is said to be reversible if a change is brought out in such a way that the process could at any moment be reversed, okay, by an infinitesimal change. Infinitesimal means extremely small. A reversible process proceeds infinitely slowly by a series of equilibrium states such that system and the surroundings are always in near equilibrium with each other. Okay, this is reversible process. Reversible process is carried out in infinite time, in infinite steps. Okay, and this is very slow. Irreversible process. Processes other than reversible processes are known as irreversible processes, and all natural processes are irreversible. Now just see the differences between reversible and irreversible process. Reversible process. The process is carried out infinitesimally slowly, while irreversible process carried out rapidly. At any stage, the equilibrium is not disturbed. In this case, equilibrium may exist only after the completion of the process. Reversible process, it takes infinite time for completion, while it takes a finite time for completion. In case of reversible process, work obtained in this process is maximum, while in this case, work obtained in this process is not maximum, and reversible process imaginary, while irreversible process is natural. Okay. Now this you can also understand. See, this is the one gas is filled in this. Okay, and the pressure of the gas is maintained by this piston. If we want to expand this gas, and suppose if we want to expand this gas up to this level, okay, then what we will do? We will move this piston outward, okay, in some finite steps or in one step. That's why process is carried out rapidly. Okay. Now again consider one situation. Gas is filled there and same pressure is maintained in this situation by a heap of sand. Okay, heap of sand, same pressure like this. Now again, if you want to expand up to this level, and for this expansion, what we will do? We will remove one particle of sand one by one. Okay, we will decrease the pressure by removing sand particle one by one. Now you can imagine in how much time and in how many steps this process will complete. Okay, this is the example of a reversible process and this is the example of irreversible process. Okay. Now, if the compression of gas is carried out in a number of finite steps, work done on the gas will be summed over all the steps and will be equal to sigma. This symbol is for sigma, that is sum up, P delta V. Okay, and this is a graph between pressure and volume, PV plot. When pressure is not constant and changes in finite steps during compression from initial volume Vi to final volume Vf, work done on the gas is represented by the shaded area. Okay, this one. Okay, this work is done in one step. This is in another step. Okay, this is in another step. If you want to find out the total work, then we have to sum up it. Is it clear? This is a irreversible process. Now come to pressure volume work in reversible process. If the compression of gas is carried out in infinite steps, okay, infinite steps through reversible process, at each stage of compression, the volume decreases by an infinitesimal amount, that is dV. Okay, now there is no large change in the volume. Volume is changed, or volume will decrease by very small amount, and that is represented by dV. In this case, the work done on the gas is calculated by the following relation. This is. Now, in this case, we will integrate this relation between these two ranges, V initial and V final, and this is the symbol for integration. Is it clear? Now here, this is P external at each stage is equal to P internal plus dP in case of compression. If we are compressing this gas, okay, then whatever the external pressure we are applying, this external pressure is very slightly greater than the internal pressure, okay, and this slight change in pressure is represented by dP. But if there is an expansion work, then we have to decrease the pressure, and that's why this is P external is equal to P internal minus dP. And in general, we can write P external is equal to P internal plus minus dP. Now, in this formula, if this P external is replaced by this one, then we will get this. Okay, that is W reversible. Now, this process is reversible. That's why we are writing W reversible. This is equal to minus V initial, V final integrating P internal plus minus dP multiplied by dV. Now, if we solve it, okay, then we will get this dP multiplied by dV, and this dP into dV is very small. So, this expression can be written like this. W reversible is equal to minus integration between V initial, V final, P internal dV. Now this P internal is the pressure of gas. That's why this PIN can be written as only P. Is it clear? Now as we know, this is ideal gas equation. PV is equal to nRT, and from this P can be written as nRT by V. And in this equation, W reversible is equal to minus integration in between V initial to V final P dV. Replace this P by this relationship. Okay, that's why we will get W reversible is equal to minus V initial V final integration nRT dV by V. Okay, this can be written like this. Now when this term is integrated, then we will get this one. Minus nRT ln V final divided by V initial, where this ln represent the natural logarithm. What it represent? Natural logarithm. And when this natural logarithm is converted into base of 10, then this ln is replaced by log, and this whole term is multiplied by 2.303. That's why we will get W reversible is equal to minus 2.303 nRT log V final divided by V initial. You have to remember this relationship. This is for pressure volume work in reversible process. Okay. Now again, for reversible process, if we plot between pressure and volume, then we will get like this. This is PV plot when pressure is not constant and changes in infinite steps, that is reversible conditions during compression from initial volume Vi to final volume Vf, and in this work done on the gas is represented by the shaded area. This area represents the work done in reversible process. Is it clear? Thank you. Subscribe my channel to get the new videos from this chapter.